Yeah. I don't think I've ever taught a grade 9 who's like, oh yeah, I know the answer to this. Boom, here it is. So let's talk about these. Some of you guys needed a review on what integers meant. Integers, this word integer, are the positive or negative whole numbers. So 1, 2, 3, 4, 5, -6, -5, -4, -1, 0, 1. These are all, well, and the first one was a lot more than 3, but consecutive integers are integers that come one after the other. So an expression for these isn't bad. Like, if I asked you to give me an integer, guys, an integer, and you perhaps didn't give me an expression for an integer you don't know. That's just a value you don't know. You give me a variable. An integer you don't know is x. Well, how do I get the next one? What's the integer that comes after x? Relate it to x. X plus 1, you bet. The number that is 1 after whatever this integer is. So if this x is 4, then this guy would be 4 plus 1, which is 5. 5 is the integer that comes after 4. So then if I wanted another one, what's the integer that comes after x plus 1? X plus 2, or x plus 1 plus 1. That's an example of how you can get 3 consecutive integers. Nice and easy. Once you know kind of how to proceed. The really gnarly ones come when we start talking about odd integers. But before we can talk about odd integers, I want to go down here. I want to add one to the bottom of your page. Abdallah, is it Abdallah and Abdullah who keep muttering? I don't know where this conversation keeps coming from. I hear guys over here. Stop talking. Let's talk about 3 consecutive even integers. Because the consecutive integers aren't abundantly difficult. It's x plus 1, and x plus 2. Before we can talk about the odds, we kind of have to talk about the evens. Because to take an expression or a value you don't know and to guarantee oddness is actually a little difficult. It's easier to guarantee evenness. If I took a number, any integer rather, I'll say, and I wanted to make it even, what one operation could I do to any number to ensure it was even? Multiply it by 2. That guarantees evenness. The definition of an even number is a number that's divisible by 2. So if I wanted to guarantee that I had consecutive even integers, I would start with a number I know is even. 2x. I don't know what x is. It doesn't matter what x is. As soon as I double it, I'm guaranteed that this thing right here is even. What's the one that comes after this one? I'll give you a list of just, before Hassan gives us the answer. I'll give you a list of even numbers. 6, 8, 10, 12, and 14. How do you get from one number to the number immediately after it? Yeah, if I'm at 8, I want to add 2 to get to 10. If I'm at 10, I add 2 to get to 12. So a way to get the next even integer, if I'm starting at this guy, is to take this one, 2x, and add 2. Hey, Steph, what's up? It can again. Nope, not regularly. No worries. Irregularly he is here, but not today. Okay, and so if I wanted to take this guy, and I wanted to find the next one, I would just add 2 again. I went from 8 to 10, from 10 to 12. 2x plus 2 plus 2 is going to be 2x plus 4. This would be an example of consecutive even integers. Now, I don't have to stay, this doesn't have to be the expression every time, just like this didn't have to be the expression every time. If I wanted integers, I could start with x plus 2, and x plus 1, and x plus 2, or I could have gone backwards. You could go backwards with these ones too, but I digress. We'll come back to that idea if we have to. To do the odd integers are a step away from the evens. If I wanted to talk about 3 consecutive odd integers, so the positive and negative whole numbers, I want them to all be odd. The only way to, are we okay? The only way to go about doing that is to first, the only way to guarantee a number is odd is to guarantee that it's even first and then move off of it. So to guarantee an odd number, first I force whatever I have to be even. And then how do I get to an odd number from an even number? Add 1 or you're sure, or 3 or 5 or 7, or subtract. So I could have 2x plus 1. If that's my first odd number, the odd numbers are things like 1, 3, 5, 7, 9. These guys are also 2 apart from each other. So if I start here at 2x plus 1, and I wanted to get to the next odd number, I could just add 2 to this. 2x plus 1 plus 2 is 2x plus what? Plus 3. And then the odd integer after this would be 2x plus what? 5. If you follow the pattern, it'd be 2x plus 5. And that's it. Not something I would necessarily expect you to just unearth on yourself, though you could. Some of you may have seen this before. But these are the ways we're going to start to think about constructing some of these ideas. Like there are mathematical ways to generate lists of consecutive numbers or odd numbers or even numbers or whatever it is that we're wanting for. And I wanted you to at least see it, have a chance to think about it. Okay, flip the page. We're going to launch, I'm going to do 3 examples. We're going to launch into this. And then we're going to call it, and I'll let you play with some easy ones. And like I said, Monday you get the gross ones. So here we go. On Wednesday, I gave you guys this page of operations words, and I gave you this task to just start to get you guys thinking about how you convert English language, whether it's a sentence or whether I speak it to you, into mathematics. Expressions that we can use to start to solve stuff. And that, I gave you that on Wednesday so that today and Monday, we can lead into these kinds of questions here. So, I got 2 that are similar and then 1 that starts to bring in some more word, like legitimate word problem kind of ideas. And I'm going to show you a framework that I'd like you to follow. Here we go. So, here's the question. 7 times a number is the same as 12 more than 3 times the number. Find the number. Now, having just read that, I'm not going to jump right away to pulling out letters or mathematical expressions. I want you guys to identify for me first what the important words are in this 2 sentences. There's all sorts of them. What language in here is going to tell you to do something with math? Yeah, give me one. Times, and times shows up twice. Here it's 7 times the number, and over here it's 3 times the number. This tells us we're going to be multiplying stuff. Cool. What other language in there? Lucas, do you have this booklet up? Okay. I've got a stack of extras. Come grab. Okay, 7 times the number. And what else? What other language in there? Yes, Japri. Are you dying? Yes. The big stack right here. No, closer to me. Yeah. If you go down a little bit, you'll see this. Okay, what else in there is telling us about math? Japreet, before you go, you have to tell me a math word that's on the screen. A word in there that's talking about math. No, it doesn't say variable. It's 7 times the number is the same as 12 more than 3 times the number. 12 is a number. Yeah, that's a number word. Sure, I'll give it to you. Get out of here. That's cheating. That's not a word I was looking for. But she's dying, so we'll let her go. Someone other than Hassan Joe, because Hassan Jude will do the whole question for you. Which some of you might be... Sorry? No. Akam, give me a math word out of that sentence.
Number.
A number. Okay? If we're talking about a number, do we know what the number is? No. Let's call it X. Sure, the A number is important there. Cool. What other language is in there? There's a few more things in there that we can pull out that mean stuff. Don't just give me the words for numbers. 7 and 12 doesn't count. Yeah? More than. More than means we're doing what mathematically? We're adding. More than is an adding word. Cool. There's at least those 2 more things I want to talk about out of this. Let's see if you can find them. Josh, I heard ya. Oh, no, that wasn't, you weren't answering?
Yeah, he was trying to answer. He was telling me to answer, and he's like, no, just...
No, he wasn't, but that's okay. Oh, okay. Well, let's go to Faison then. Faison, do you see any math words in there? I know it's last block on a Friday. I'm asking a great deal of you. Sean. Thus, well, let's go to the whole phrase. Thus is the same as. Is the same as is what mathematical symbol? Equals. And there's one more part of this phrase that's important. Take them hands to yourself. Sorry? Did someone say something? Okay, the other important phrase here comes near the end. The number. Why is the number important? That word the is wildly important. But we know something about it. When this language here of the number, yes, the number is the same as the a number that was referenced earlier. It says, so let me read it again. It says 7 times a number is the same as 12 more than 3 times the number. This number, the number, put your phone away. No, and the a number, you weren't on your phone? Put it away. They're the same. And when 2 unknowns are the same, what can we do with those unknowns? No. Use the same variable, yeah. So both of these, the a number and the number, reference the same variable. And so now we can actually go ahead and start building this equation. When you start these things, the first thing you want to do, Akam, Josh, and Faison, is to identify the thing that you're looking for. What are you looking for? In this case, we want the number that satisfies this expression. So like there are word problems where it might be the cost, or the number of trees, or the value of a phone, or the number of apples, whatever the question might be getting at. In this case, all we're asked to find is the number that does this. So the number that we're looking for, we're going to give it a name. Someone already called it X. So there we go. We've got our X. We only have one unknown, so we can skip over this step. This one says to express the unknowns in relation to the first. Well, we can skip that part because we only have one unknown. We'll come back to that in our next example. So now we can complete an equation. We know, well, if we read the thing again, 7 times a number. 7 times a number is just going to be written as what? 7x. You bet. Is the same as is equal to, it's the same as what? 12 more than, so I'm going to take I'm going to add 12 to something. It's 12 more than what? 3 times the number. 3 times the number is 3x. So now we're going to isolate, that's the hard part. Now we're going to isolate this thing. We're going to find out what that number is. My first step to getting x is to do what? Yes, whoever said move the x's to the left. How do I do that, Faison? No, don't cross out the 3. Josh, I'm going to take away 3x. You betcha, because I'm adding 3x, I want to take it away. And I take away on both sides. So 7x minus 3x is 4x equals 12. I don't want 4x, I just want x. So what do I got to do? Yes. Yes. X equals 3. And we can check it the same way we did before. We take the value we got, we put it back into our original equation, and we're good to go. If it works, we are too. Okay, sorry? You want me to demonstrate that? No? Okay. Next one. Oh, we're not done. Because the question was given in words, the answer needs to be given in words as well. The number is 3. Boom. Piece of cake. Maybe, maybe not. When you're ready, flip the page. Let's make it more interesting. Okay, so for this one, I am going to show you 2 different ways to do the exact same question. Here we go. So this one says the sum of 2 numbers is 50. 3 times the smaller number is equal to 2 times the larger number. What is the smaller number? So this question has an extra bonus sentence. The previous one just said 7 times the number is the same as 12 more than 3 times the number. Find the number. It was one sentence that related everything together. Here I've got 2. I've got this guy. The sum of 2 numbers is 50. And I have this second piece. 3 times the smaller number is equal to 2 times the larger number. What is the smaller number? So there's all sorts of important language here. It's the same as it was before. What are the important words that we're going to want to pull out to turn into math in a little bit here? The sum. Sum means I'm doing what? Addition. Cool. What else is important here? Times means we're multiplying. Good. Times shows up twice. And the last step here is, well, the last important word here is, yeah, this phrase, is equal to. That's just an equal sign. So let's identify some variables. What are we looking for? The smaller of 2 numbers. So the variable is the smaller number and what do we want to call it? Sure, we can call it x again. What about y? Someone said x first. If you wanted y, you should have said it a second earlier. Now, this next step is where these 2 different methods separate. I'll show you this method first. We've identified what we want to find. We want to find the smaller number. We gave it a name. We called it x. But we're told in the question that there are 2 numbers. What's the relationship between this smaller number and whatever the other number is? If you add them together, this smaller number and some other unknown number, they're going to add to 50. Okay? So what that means is there's another number. It's a larger number. the larger number equals. That's the other method. On the right-hand side, the larger number equals y. On the left-hand side, the larger number does not equal y. And on the left-hand side, we want to find a relationship. We do not want to introduce another variable. So the two ways to do this kind of question are with two variables, x and y, or with just one variable and a related expression. I'll show you the difference between the two. So if I have two numbers that add to 50, and I call one of them x, how could I find the other one? I'll give you some values and maybe this makes sense. What if x turns out to be 10? What will the other number have to be? Yeah, Emerson, it'll have to be 40. How'd you get that? Because 40 plus 10 is 50. What's the other way to think about that exact same idea? Anybody? Sorry? Sorry, Akam? Okay, well, I said if x happens to be 10, the other number will have had to have been 40 because Emerson said 40 plus 10 is 50. What's the other way, instead of thinking that 40 plus 10 is 50, what's the other way that we could have found that value 40? No, we're not there. Just looking at this first sentence. If the sum of two numbers is 50 and the other one is 10, when one of them is 10, the other one has to be 40. Yes, 50 plus or 40 plus 10 is 50. I don't know, it's interesting that this is so difficult for you guys to wrap your heads around. The other way to think this through. And it's you guys have been doing it all semester. My other nines have been doing it too. All my nines have been doing it. You guys hate Samira? Subtraction. We hate subtraction. I don't know why. If one of the numbers is x and it adds with another number to 50, that means the other number, the larger number, needs to be 50 minus whatever this value is. This sentence right here, if two numbers add to 50 and one of them's x, the other one has to be 50 minus x. This guy here gives us that guy right there. If two numbers add to 50 and one of them is known, the other one is 50 minus the known one. Going back to my example, Emerson's right. If x is 10, the other number has to be 40. Why? Well, because 50 minus 10 is 40. Okay, so now we can start building our equation from the second sentence. Hassanjo was about to reference that 3 times the smaller number, so the smaller number we called x, 3 times the smaller number x is equal to, you guys said that that was an equal sign, it's equal to what? 2 times the larger number. Well, the larger number we now have an expression for, 50 minus x. So now this is my equation that I want to go ahead and solve. I managed to do it with only using one variable. What's my first step here to solve this thing for x? Hassanjo. Yeah, we're going to multiply the 2 in. So I'm going to get 3x equals 2 times 50 is 100. 2 times negative x is just negative 2x. Next step is to do what? Add 2x to both sides. So the negative 2x plus 2x cancels. 3x plus 2x is 5x equals 100. I want to get x by itself, so we're going to divide by 5, and x is going to equal what? 20. If x is 20, then the larger number must be 30. So yeah, 20 is the smaller of those two numbers, so we're good. That works. That's one way to do this problem. The other way to do this exact same problem is what you guys yelled out right at the beginning that I didn't want to do. Here we go. Let's do it again. If the smaller number is, let's wind back my conversation. I asked you if the smaller number is x, what's the larger number? And your gut reaction was to say, well, the larger number is y. As soon as you introduce a second variable, now we've got two variables, you're going to have multiple equations, and you need a specific technique to deal with that. The technique that I'm going to introduce you guys to is called, I'm going to put it up at the top here, substitution. Let's do it. So you've introduced a second variable. You said the larger number is y. Now when you do that, we're going to have to write down both of these relations. If the sum of two numbers is 50, that's going to make our first equation. The two numbers are x and y, and we're told that they sum to 50. So x plus y equals 50. That's going to be our first equation. The second equation comes from the next sentence. 3 times the smaller. Well, you guys said the smaller was going to be x. So 3 times the smaller is equal to 2 times the larger. Now you said this time, you said the larger was y. So here is how substitution works. Once you have two equations, here are the steps. You pick an equation. It doesn't matter which of the two you choose. And isolate one variable. There are often easier ways, like sometimes there's easier equations to choose, but it doesn't matter because you will still get the same result either way. So, I don't know, who am I going to pick on? Matthias, haven't heard from you much today. Which of those two equations do you want me to isolate? For which variable? You want me to solve the first equation for x? Okay, so if I do that, Matthias has picked the first equation, x plus y equals 50. To isolate for x means I'm going to subtract y on both sides. So that's going to cancel, and I'm going to get x equals 50 minus y. The second step is to replace the isolated variable in the other equation. So I said that x equals 50 minus y. What we're going to do now is we're going to take this. If x is equal to 50 minus y, I'm going to take 50 minus y. I'm going to move it up to the other equation, and I'm going to put it where x was. So by doing that, what I get now is this. The 3 stays where the 3 is, and I'm going to replace x, like we've been doing with our checks and stuff. We're going to replace x with this expression here. So I'm going to put brackets where x was. There's a whole ton of you that are just kind of off in other places. I want to encourage, like, take these notes, do this with me, do this process, because when I leave you to do it on your own, I mean, you might say right now that you have no idea what's going on. You'll have less of an idea what's going on if you make no effort to try. So I'm going to take this 50 minus y, I'm going to put it where x was. So now I'm going to get 50 minus y right here equals, the other side of the equation stays the same. And now we're going to solve this thing. I'm going to distribute in the 3. So I'm going to get 150 minus 3y equals 2y. We're going to add 3y to both sides. I'm going to get 150 equals 5y. I'm going to divide by 5, divide by 5. I know I'm writing quick. Those are going to cancel. Y is going to equal what? What is 150 divided by 5? It's 30. So we have found a value for y. Because Matthias said, let's solve for x. Okay, well, we found a value for y. Now we go all the way back. What have we found? Well, y, we said, was, you guys said earlier, was the larger number. The question, have we answered the question? Josh, what does the question say? What's the question say? What's the question asking us to find? Have we found the smaller number? No, we found the larger number. Akam, keep your hands to yourself, or so help me one more time you can go. I don't want to find y. I wanted to find the smaller number, which you guys called x earlier. So what we're going to do is we're going to take this value for y, and we're going to shove it back in there. X equals 50 minus y, so it's going to be 50 minus 30, so x has to be 20. Oh, look! It's the same thing we found before. It's a lot more work, but that's what you need to do as soon as you introduce a second variable. So if you can avoid it at the outset, I'd avoid it. So this is substitution. Questions about what I've done? Or do you just need some time to take it all in? Okay, I have one more example and I'll demonstrate both methods again. And then I'm done. Oops, wrong way. Flip the page. One more example. Here's the question. I have two phones. A 16 gigabyte phone costs $75 more than an 8 gigabyte phone. Together they cost $725. How much is each? Now your intuition, this was the problem I had with the other class. I had a bunch of students in the other class who said, oh yeah, this is really easy. You just do this, 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 and then you're done. But they didn't have any mathematical reasoning for it. They just did a bunch of shortcuts. And all I have to do if I want to kill the shortcut people is make the question slightly more difficult. And now your intuition will fail you and the shortcuts won't work. There are shortcut ways to do this problem. But I want you guys to be able to demonstrate a method. And these are the methods I want you to be able to use. One of them. So let's do the same question two ways. The same set of steps that we did before. We want to identify a variable, express the unknowns, and we want to complete the equation. So, what are we trying to find? We want to find two things. We want to find the cost of a 16 gig phone and cost of an 8 gig phone. These are the things that we're looking for. Now, there is let's try the one variable way first. The one variable way says, give a variable to one of the things we're looking for. What variable do you want to use for one of these things? Someone other than Hassan Joe. Lucas, you had an opinion before. Let's go with you. Sorry? You know the answer already. What are the costs of the two phones? Excellent. Let's prove it. How'd you do it? Yeah, you minus 75 and divided by 2. Yeah, that's the same shortcut. That's the same. So if you're sitting there like, I know the answer to this question, I don't need to do this question. Yes, it is the answer. But that's not, and that's the thing I'm fighting against in all of my blocks. I don't care what the answer is. The goal is not the answer. The goal is to give you guys sets of tools and techniques. Lucas, if you don't want to be here, if this is such a big deal, then go for the week. Then go. There's a lot of shaking of the head and moaning and rolling of the head. I get it. You don't want to learn what I'm trying to teach. But that's the point of what I'm trying to do here. Ultimately, I don't care what the answers are. I don't care that the cheaper one is $325 and the more expensive one's $400. That's true, but we need a method for this. And I'm going to use this relatively easy question for some of you as a tool to try and teach you a method. So let's do it. Someone else, give me a variable for one of the things we don't know.
The 16 divided is x.
Sure. Don't introduce. Yes. So the cost of the first one is X. This is the more, and it says the 16 gig phone costs 75 more than the 8 gig phone. So this one is the more expensive one. So if I don't want to introduce another variable, Matthias said the more expensive one minus 75 is going to be the cost of the cheaper one. So the cost of the 16 is X, the cost of the cheaper is 75 less than X. I could have gone the other way. I could have said that this one was, I don't know, Y, and then the more expensive one would have been the cheaper phone plus 75. It doesn't matter which way you pad this out. But Matthias said, okay, this one's X, so this one's going to be 75 less than it. And so now we were going to use these to build the second equation. It's not an overly difficult equation. Together they cost $725. So the cost of the first, X, plus the cost of the second, X minus 75, those are going to add up and give me 725. And now I've got something to solve. I can group my like terms. 2x minus 75 equals 725. I'm going to add 75. And I'm going to get 2x equals 800. I'm going to divide by 2, and we're going to find that the cost, or the value for x, is 400. Well, what was x? X was the cost of the 16 gig phone. Lucas was right. The 16 gig costs 400, so the 8 gig is going to be 75 less than that. That's going to be 325. We've got both costs. But again, getting you guys comfortable with and being able to regurgitate a method is what I want to see. Trying to teach you techniques. So let's do the other technique. Let's look at substitution here. So substitution looks like you guys introducing two variables. So let's say that the cost of the 16 GB phone is X, and the cost of the 8 gig phone is Y. If you're going to introduce two variables, you need two equations. We know that one of them, the 16 gig phone, costs 75 more than the 8 gig phone. So that means the 16 gig phone costs or is equal to 75 more than the 8 gig phone. That's going to be Y plus 75. So that's this equation came from this first sentence here. So then together they cost 725. So the second equation is going to be X plus Y equals 725. This substitution example is easier than the one we just did because one of the equations is already isolated for one of the variables. The first equation is isolated for X. So all I'm going to do is I'm going to take this expression that X is equal to, and put it in for x in that second equation. We'll get y plus 75 plus y equals 725, and now we can go ahead and solve this thing. I group my like terms. Y plus y is 2y plus 75 equals 725. We're going to subtract 75 on both sides. We'll get 2y equals 75 minus 75 cancels. 725 minus 75 is 650. Divide by 2, divide by 2. Y is going to equal 650 divided by 2 is 325. So now I've got the cost of the cheaper phone is 325. The more expensive one is 75 more. So the 325, which I can put in this equation right here, plus the 75 is equal to 400. That's the substitution technique. Yes, I am aware middle schools are all about the shortcuts, and you guys like your shortcuts. The shortcuts don't help as soon as things get slightly more complex. That's it. There's my lesson. What I'd like you to do, I'm going to start, if you want to start with some easy ones, there's only about 15 minutes left in the block. If you're like, yes, I want to get a handle on some of these, I want to get a little bit more comfortable with these things, take a look at these questions. Page 15 to 17 odds. If, on the other hand, you'd like something more challenging, would anyone like something more challenging? Or do you want the easy ones for now and you come back to the hard ones on Monday? Hard ones for Monday or hard ones now? If you want the hard one, Monday? Okay, sure. If you want the hard ones, flip ahead to here, where it says general word problems. These ones get a little bit more involved. Yeah, you can take a look at these ones too. At the end of the day, you still need you need to look at all of them, but there's some easier ones. I want you to get you to do odds on. Page 15 to 17 odds. This is page 15. But if you want to up the ante a little bit, jump to here. They're not ridiculous, but they're slightly more involved. And we'll spend Monday finishing whatever you don't finish. There you go.